Students, we're talking about the Address Resolution Protocol or ARP. हम लोगों ने एक ARP protocol की location को study किया था. That it's an auxiliary protocol at the network layer, and then how the ARP protocol takes in the IP address from the network layer and converts it to the corresponding link layer address or the physical address. Students, up slide पे चलेंगे and we'll study the operation of Address Resolution Protocol or ARP in further detail. Students, as you can see on the slide, we have got a system A which needs to send its data to system B, and we have got some intermediate nodes as well. In the first case, we have got an ARP request or an Address Resolution Protocol request, and the second one is an ARP reply. Students, मैंने आपको बताया था कि ARP request is always a broadcast. So the address, the link layer address that you're going to be using for the ARP request is the broadcast address. Students, in the case of the ARP reply, this is always going to be unicast. And I'll explain. Students, request ko dekhte hain pehle. System A, which has got an IP address of N1 and L1, wants to send something to system B, which has got an IP address of N2 and L2. Students, गौर कीजिएगा, ARP request उस वक्त generate होगी when your system A is looking for the link layer address of a node with an IP address of N2. So essentially, system A does not have L2, which is the link layer address or the physical address of system B. And this is what we are trying to find out using this ARP request. Students, the request is sent. You can see the request here. The request is sent in the form of a broadcast. The broadcast is received by all entities that are sitting with the next connecting device. In this case, it's received by this machine out here, which has got an IP address of N4. It's received by the machine which has got an IP address of N3. And it's also received by our destination host or system B, which has got an IP address of N2. Students, once system B receives it, it recognizes its IP address, and what it does is it actually creates an ARP reply. And in this case, this is no longer a broadcast. This is a unicast, so it just uses the unicast address of system A and it sends a reply directly back to system A. Unicast means the ARP reply or the response is sent directly to system A, and this ARP reply will contain L2, which is the physical address or the link layer address of system B, and therefore system A can then use it to send its frames or whatever information that it has to system B. So students, this is how the Address Resolution Protocol, the request, ARP request, and the ARP response works. Students, there is an additional concept that is called as caching that is also related to ARP, and we'll talk about that before we conclude this discussion. Students, caching jo hai, in the caching, the system A, it actually caches or stores the link layer address of system B once it's received. Students, ye jo concept hai caching ka, this is there to remove the need or the requirement for system A to send broadcasts every time it needs to send something to system B. Ab students, agar har baar, whenever system A needs to send something to system B, or whenever system A wants to broadcast this ARP request, if this is done every single time, then that is not an efficient use of our resources. Students, another question that is answered by the concept of caching is, why can't system A use the same broadcast packet or the frame to send the information that it needs to send to B? Students, normally the amount of frames that we need to send from one source host to the destination host is a huge number. Every time if we actually decide to send this using the broadcast packet, that is going to actually collapse our data communication system. It's an inefficient use of our links and the bandwidth that's available on the link. Every single time, not just the destination host, but all the hosts that are present on that particular link, all those entities will actually receive this broadcast message. They will have to activate the ARP protocol. They'll have to go in, open the header and have to look at the payload and the link layer address or the IP address of the destination, and because it's not their IP address, they will need to discard that particular frame. So students, once the system A gets to know the link layer address of the destination, which is system B, it stores that link layer address in its cache, in its storage, and therefore all the future transmissions from system A to system B are normally unicast. They're always going to be unicast.